This is the sheet metal cutting device team. Our mentor is Dr. Jiang, and our sponsor is NDSU Department of Mechanical Engineering with Rob Saylor. And our team is Andrew Christianson, Zach Waite, Charles Bakken, and Casey Stark. The goal of this project is to provide a custom cutting device for the ME department at NDSU. The department currently has a table saw but lacks many features that current marketplace table saws have. It is missing parts which make it hard for both experienced and unexperienced operators to perform accurate, quick, and safe cuts. The solution to this problem is a modified panel saw concept. The main modifications include telescoping rods, removable bottom panels, clamping system, and the saw's linear rail system. All of this was done to meet the customer's requirements and engineering modifications.
The customer requires the panel saw to be able to cut sheets of metal and wood at various sizes and shapes. It must perform at a high accuracy that will require the addition of a sheet clamp. The lab is limited in space, so the panel saw will need to be collapsible for storage purposes. The design targets are to cut sheet material as large as 4 by 10 feet to as small as 4 by 4 inch sheets. It must cut at an accuracy better than 1/32 of an inch for both horizontal and vertical cutting. It must be collapsible to store in a 4 square foot area while being able to assemble and disassemble in under 5 minutes while collecting 95% of dust. Our modeled concept is a panel saw that is broken into two parts. The telescoping rods are adjustable for large sheets while serving as an effective storage solution, breaking the saw down from 10 feet to 3 feet of width. The material is stabilized by two spring-loaded clamps that attach to the linear rails. The manufacturing process began by mounting square tubing to the back of the panel for support. The panel was mounted to a C-channel rectangular base at a 75-degree angle. The telescoping rods with plastic strips were welded to the back of the panel, while a 6-inch section of the bottom base was welded to the panel to attach the other removable sections with cleats. The saw was mounted to a plate and connected to the panel using angle irons with linear rails and guides.
The performance of the panel saw was in general a success in reaching most of the targets. However, there were a few minor failures, such as the ability to clamp material while cutting horizontally. After meeting with Rob Saylor, it was discussed that this was not mandatory. Also, the panel saw cannot cut 4 by 4 inch sections while being clamped, as the clamp cannot be within 4 inches of the blade. A recommendation to improve this panel saw would be to powder coat it, as the saw is made from steel and over time it will begin to rust. Also, adding a rack on the back of the panel saw for the bottom panels when broken down to allow for the dust collection vacuum to be stored on the base of the panel saw instead of freestanding. We would like to give a big shout out to the ME Department's Rob Saylor, along with our mentor Dr. Jiang and our professor Dr. Miri, in helping us create our project. Thanks everyone for watching.